মিস্টেক হয়ে গেছে সরি এবার দেখেন এটা 4 PM যে ভিডিওটা
4 PM
এসে গেছে ক্লাস 11 ফিজিক্স 4 PM দেখুন ক্লাস 11 ফিজিক্স 4 PM আছে
চলে এসছে।
তাহলে এটা দেখতে থাকুন আর ওই ওই ডিউটিটা আপনি টাইম হলে চলে যাবেন আমি তাহলে আপনাকে আর বলবো না কিছু
ঠিক আছে।
Okay, good afternoon to everyone. We are going to do significant figures today. This is a part of the chapter units and measurements. You are having a geometry box scale with you, okay? You are having a standard geometry box scale in your hand and you want to make a measurement with that scale. You want to use the scale of your geometry box and you want to make a measurement with that scale. Now, suppose the measurement which you want to do, that measurement is 6.1 centimeter. Okay, with the scale of your geometry box, the measurement is 6.1 centimeter. So, you have decided to measure something which is 6.1 centimeter. So when you say 6.1 centimeter, then this 1 is actually actually called this 1 which we are having 6.1 centimeter. So this 1 we call it uncertain, and 6 we say that it is certain, because the thing is that you have measured 6.1, but you are aware that your geometry box scale it can measure 6.1, it can measure 6.2, but it cannot measure anything between 6.1 and 6.2. So in your geometry box scale, you have decided to do a measurement of 6.1. You have decided to measure something and you found it is 6.1 centimeter. So maybe actually the answer is 6.2, maybe the answer is 6, but you have got 6.1, right? You just measured it and it came 6.1. So the digit 1 is uncertain, as in you could have made a mistake. Instead of 6.1 it could be 6.2, instead of 6.1 it could be 6. The problem is that in a geometry box scale you cannot measure anything between 6.1 and 6.2, you cannot measure anything between 6 and 6.1. So that is why this digit is called uncertain, whereas this digit is certain, 6 is certain. And if you want to measure something which is between 6.1 and 6.2, then you will need a different kind of instrument. In fact, there is an instrument called vernier caliper, there is an instrument called screw gauge. So you have some other instruments where you can measure even 6.12 centimeter and so on. But in a geometry box scale you can't. So this significant figure topic is very relevant, because this topic is related to the measuring instrument which you are using. And in a geometry box scale, you cannot have a better measurement than the first place of decimal. You cannot have. So that is why we say that there are two significant figures. So all the certain digits and the uncertain digit, all the certain digits are part of significant figures, and the one digit which is uncertain, all of them put together, right? They are called significant figures. So if you say 6.1 centimeter, then there are two significant figures. So everything that is certain and the one digit which is uncertain, that whole thing together is called significant figures. So 6.1 centimeter has got two significant figures, right? Okay, now suppose let us say that I want to measure something whose measurement is 600 millimeters. Okay, I want to make a measurement of 600 millimeters. Let's say I'm interested in making a measurement of 600 millimeters. So if So suppose if you have a scale, suppose if you have a scale, suppose if you have a scale in which the markings are in millimeter. Suppose you want to make a measurement, you want to measure something, let us say that you want to measure something which is 600 millimeters in length. So your scale has marking in millimeter. So 600 millimeters, so 1, 2, 3, so all three are significant figures. Like 1, 2, 3, all of them are significant figures because your scale has marking in millimeter. Okay, now suppose let us say that suppose let us say that your scale has marking in centimeter. Okay, so if your scale has marking in centimeter, then actually this measurement should be read as 60 centimeter, not as 600 millimeter. So this should be read as 60 centimeter. So in that case there will be two significant figures because if your scale has marking in millimeter, then this has to be read as 600 millimeters, so there are three significant figures. If your scale has marking in centimeter, then this measurement has to be read as 60 centimeter, and in that case there will be two significant figures, right? Now so if your scale has marking in meters, then in that case 600 millimeter will be considered as 0.6 meter. So 0.6 meter will be somewhere between 0 meter and 1 meter, and that means that if you are measuring 600 millimeter, then you have three certain decimals, so there are three significant figures. If you are measuring 60 centimeter, there are two certain digits, so two significant figures. If you are measuring 0.6 meter, you have one doubtful digit, that is 6, which is after the dot, so that will be one significant figure. So here there are three significant figures because you are having three digits and all of them are certain. Here there is two significant figures because there are two digits and both of them are certain. Here you are only having one significant digit because there is a 6 after the dot, and before the dot there is a 0, nothing is there. So after the dot there is a 6, so only one significant figure. So these three are all certain, these two are certain, and this one is doubtful. So the total number of certain and doubtful, uncertain are synonymous. The total number of such digits is called significant figures. So this is a very strange thing that is happening. When I am measuring 600 millimeter with a scale whose markings are in millimeter, then there is three significant figures. When I am using a scale whose markings are in centimeter, then two significant figures. And when I am using a scale whose markings are in meter, then one significant figures. That means we are getting three different answers for the same measurement. So to resolve this issue, the scientists they gave a suggestion that so to resolve this issue, the scientists they gave a suggestion to resolve this issue, that instead of writing it like this, you write it as a power of 10 with a multiplier. So you can write 600 as 6.00 into 10 to the power 2. Now why is that important? If you write 6.00, then 6 is the first digit, then after point there is a 0, so that is the second digit, so they both are certain, and the last 0 is uncertain. So total there are three digits, so there are three significant figures. If you write 6.0 into 10 to the power 2 millimeter, that is also 600 millimeter. So 6 is certain and the 0 after the decimal is uncertain. So total there are two significant figures, which is the truth. And if you have 6 into 10 to the power 2 millimeter, then there's only one digit and that is certain, and that is also all these three are 600 millimeter. But if you write it as 6.00 into 10 to the power 2, there are three significant figures. If you write 6.0 10 to the power 2, there are two significant figures. If you write only 6 into 10 to the power 2, there is only one significant figure. So if you write it as a power of 10 with a multiplier, then you will get the correct number of significant figures. And that you will not get, or rather there will be a lot of confusion if you try to do it in this way. So the suggestion given by scientists was that when you have a complicated situation like this, that a measurement 600 millimeter could have so many significant figures, different types of significant figures depending on how you are measuring it, then it is better you do the representation like this. Okay, if you have a measurement like this, 0.0023. Now we haven't done any question like this till now where there is a 0 before the first non-zero digit. I mean, we have done one, this last one, 0.6. This is the only one. So remember, before the first non-zero digit, whatever zeros are there, they are not counted. So if you say 0.0023, then all these three zeros are not counted. Whatever zeros are there before the first non-zero digit, they are not counted. So don't count this, don't count this, don't count this. So two significant figures. But if the measurement is 1.0023, then 1, 2, 3, 4, 5, you have to count all 5. So 5 significant figures. So this is an important thing. Don't count the zeros before the first non-zero digit. Okay, now let us see that what are the rules for significant figures in case of arithmetic operations, division, addition, subtraction and multiplication. Let's begin with division. Suppose you want to divide two quantities, let's say 12.0. Suppose there are two bodies. One body's mass is 12.0 kg, one body's mass is 7.0 kg. You are dividing them and the answer is 1.714285. So you are dividing both of them. So here what you'll have to do is that you will have to see that 7.0 has two significant figures and 12.0 has three significant figures. So 12.0 has three significant figures and 7.0 has two significant figures. So out of these two, you have to see which one is the lesser one. So the lesser one is 7.0, it has two significant figures. So according to the rule, your answer will also have two significant figures. So 1.71425, it will have to be taken as 1.7. This will be the answer. So once again, when you are doing division of two quantities, you see how many significant figures they both have. This has 3, this has 2. Then the one which has lesser number of significant figures, that will be the number of significant figures in your answer. So the lesser one is 2, so answer will be 1.7. Now, this particular answer, we said 1.7 is the final answer. Now, if it is 1.76 and if it is 1.75, then what do you do? Suppose 1.71425, you said the answer is 1.7. Now suppose it is not 71, it is 1.76, or suppose it is not 1.71, it is 1.75, then what do you do? Then the rule is, if it is 1.76, then you have to make it 1.8, which is something we are very used to in arithmetic. When the next digit is more than 5, we round off the previous one. But if it is 1.75, then also you have to make it 1.8, but suppose it is 1.85, then you have to keep it 1.8. So just listen to this carefully. 1.71425, I said the answer will be 1.7 because after 7 there is a 1, so 1 is less than 5, so forget about it. But suppose if it was 1.76, so 6 is more than 5, so if you are rounding off 7, it will become 8. Suppose it is 1.75, so in that case you have to round off the 7 and make it 8, so 1.8. And suppose 1.85, then, so what is the difference between 1.75 and 1.85? In 1.75, 7 is odd, so 7 will become 8. In 1.85, 8 is even, so 8 will remain 8. So remember, after you are dropping off 5, If the previous digit is odd, it will be increased by 1. So 7 will become 8. After you drop 5, if the previous digit is even, it will remain the same. So this is the thing. Now for multiplication also, the rule is the same. For multiplication also, the rule is the same. So suppose you are multiplying 12.0 into 7.0. If you are multiplying 12.0 into 7.0, 12.0 has 3 significant figures, 7.0 has 2 significant figures. So 12.0 into 7.0 will have 2 significant figures, so answer will be 84. That's it, no decimal. The answer will just be 84 because this has 3, this has 2. So the answer cannot have more significant figures than the one which has the least number of significant figures. So the answer cannot have more than 2 significant figures. So 12.0 into 7.0 will be 84 and that's it. That will be the answer. Now what about addition and subtraction? Now regarding addition and subtraction, suppose you want to do addition or subtraction, any one, the rule is same for both. Let's take addition. So you want to add 34.10, 4.15 and 2.1. Suppose you want to add these three. 34.10, 4.15 and 2.1. Let's say you want to add these three. So what you'll have to do is 34.10, it has 2 significant figures, this has 2 and this last one has 1. So what you have to do is, you will have to take the minimum number of decimal digits among all of them. So this one has 2 digits after decimal, this has 2, this has only 1. So you will have to take 1 digit after decimal for all of them. So 34.10 will be 34.1, 2.1 will remain 2.1 and 4.15 you will make it 4.2 because of this rule, because 1 is odd, and then you add everything. So answer is 40.4. So this is what you have to do for both addition and subtraction. So once again, suppose you are adding 34.10, 4.15 and 2.1. Suppose you are adding these. So the first one is 34.1, second one will be 4.2, third one is 2.1. If you add it, so it's coming to 40.4 and 4.15 I have rounded off 1 to 2 because 1 is an odd number. So for addition and subtraction, this is the rule. So these are the different rules of significant figures, and now I am giving you some homework for 9 p.m. tomorrow. So this is the homework. Question number 1. So round to 3 significant figures, 15462, 14.745, 14.750, 14.650 into 10 to the power 12. Question number 2. Find the value of 25.2 into 1374 by 33.3. In this question, you will have to follow the rules of multiplication and division. That means you'll have to see that out of these three, which has got the least number of significant figures. You'll have to actually do the multiplication, then actually do the division. Whatever you get, you have to use this rule and give the answer to the significant figures of the one which has the least number of significant figures. That is question number 2. Question number 3. 24.36 plus 0.0623 plus 256.2. Okay, 24.36 plus 0.0623 plus 256.2. You will have to do this addition and say the answer. Okay, that is question number 3. Question number 4. Find the number of significant figures in 1001, 100.1, 100.10 and 0.001001. That is question number 4. And question number 5, you have to give your answer to two significant figures. You have to round off to two significant figures. 3472, this is actually 3472, there is no dot. 3472, 84.16, 2.55, 28.5. Correct to two significant figures, 3472, 84.16, 2.55 and 28.5. So these are the 5 homework questions, and if you can finish them before 9 p.m. tomorrow, you can join the 9 p.m. meeting and show me your homework tomorrow. Okay. So that brings us to a conclusion of this session of significant figures. Thanks a lot. I'll conclude the session. Bye all of you.